Yeah,
Uh,
fine.
Hi,
Yeah.
sir.
Yes.
Sir, you told us you will give us some time before starting PySpark.
Already your ADF 1 month time you got, right?
Okay, okay. I thought after ADF we will get some time to practice.
No, no, no. ADF, you'll get time for that ADF, right? Already 1 month, more than 1 month time you got.
Okay. And happy Diwali, sir.
Yeah, fine. Thank you. Wish you the same, everyone. So even some people were asking, right? Today is Diwali. Today is Diwali. So, okay, but anyhow, we have announced and we have said the class. But I will take for some time the introduction to PySpark today. Yes. Happy Diwali to all once again.
Happy Diwali, sir.
Fine. Thank you.
Happy Diwali to sir and everyone in the class. Thank you.
Okay. So on a Diwali day, we are starting with this PySpark and Databricks. That it's a good day to start. Yes.
Exactly, sir. It's a very good day to start. Yeah.
Okay. So hope I'm not taking your holiday. What is Apache Spark?
1 hour is fine, sir. No issues.
Apache Spark. What is Apache Spark? So I define PySpark. Spark is a. So I define Spark in 5 lines. So in total in ADF, in Databricks, in Synapse, in total data engineering, like totally Spark is the main execution, right? Spark is an open source. Spark is an open source. Okay, I can define in 5 lines. Spark is a open source distributed execution framework. Distributed execution distributed cluster computing. Distributed cluster computing. In parallel process style. In parallel process style with in-memory computation feature. With in-memory computation feature. It's open source distributed cluster computing framework in parallel processor style with in-memory computation feature used for large scale data processing. Used for large scale data processing. Open source distributed cluster computing framework in parallel processor style with in-memory computation feature used for large scale data processing. Used for large scale data processing. Okay. So here you need to understand here in-memory computation feature. What do you mean by in-memory computation feature, right? Yes. Anyone, any idea about in-memory computation?
It utilizes the RAM, which is considered as in memory, and it is faster in terms of process.
Anyone? Yes. Generally in Spark, your data will be divided into multiple partitions and they are distributed across multiple systems and are processed parallel. That's why distributed execution, parallel processing, that is fine. In-memory computation means data stored within the RAM level, data processed by the RAM level. Generally, your data will be stored in the disk level. Your data is stored in the disk level generally, but it is stored in the memory level and processed in the memory level. You might be getting multiple queries here. Spark means this Apache Spark, mainly for huge data, right? Huge data processing. If you got 3 TB data, how can you fit it into the RAMs? If you got 3 TB or 10 TB data, how can you fit? Means I'm saying data stored in the RAM and data processed by the RAM. Then we see the concept of distributed RAM. Distributed RAM. For example, each system has got 64 GB RAM. There are 10 systems. Totally, what is the RAM capacity?
40 GB. 600.
640, no? Right.
640, right? 100 systems means 6400, right?
6,400. Yes, sir.
Yeah. Means distributed means your data will be distributed across multiple systems. Multiple systems has got multiple RAMs, right? So in this way, distributed RAM it is utilized. Parallel process time with in-memory computation used for large-scale data processing.
Sir, what does Apache represents? Apache.
Okay. Apache Spark. Sorry. Spark was introduced by. Spark was introduced by Apache Software Foundation. Apache Software Foundation. That's why we say Apache Spark. Spark was introduced by whom? Apache Spark Software Foundation. Apache Software Foundation. That's fine. Yes. And what? Okay. So just if you want, I can see the history of this.
Sure. Sir.
History of Spark.
Yes,
So before
exactly.
that, if you see the evolution of Spark, what is Apache Spark? You have seen, right? And this is defining Spark. Spark. Okay. Spark was developed by Matei Zaharia. In AMP Lab Berkeley in the year 2009. Spark was open sourced in the year 2010. Spark was open sourced in the year 2010. Spark was donated to Apache Software Foundation in the year 2013. So a lot of POCs were done from the year 2015-16 onwards, right, on Spark. It's a very high speed processing. I'll just say what is the speed of Spark as compared with other things, right? Yes. What do you mean by in-memory computation? What do you mean by in-memory computation? Once again, in-memory computation. Data gets loaded. Data gets loaded into RAM. Processed and gets processed within RAM. And get processed within RAM. Here data gets divided into partitions and these partitions are distributed. These partitions are distributed across multiple RAMs, across multiple RAMs of multiple worker nodes. And distributed across multiple RAMs of multiple worker nodes. And are processed parallelly. Multiple RAMs of multiple worker nodes and are processed parallelly. Spark can be coded with the right text. Spark can be coded with Scala language, Python language, Java language, and R language. Scala, Python, Java, and R language. It can be coded with Scala, Python, Java, and R language. Yes. By default, Spark built using Scala language. By default, Spark built using Scala language. Whenever I say Spark means, whenever you say Spark means by default Scala implementation. Spark means Spark with Scala implementation. Whenever I say PySpark, Spark with Python implementation. So in our course, right, we go with PySpark, Spark with Python. Previously, when it was introduced, right, Spark with Scala, see like 2015, 16, 17, 18, 19, 20, right? Scala was used a lot. But from the last 5 years onwards, right, last from 5 years, like PySpark is mostly preferred, where PySpark is providing some powerful libraries towards this Spark. Not only for that, for also for machine learning, for all this advanced analytics. Spark is default written in Scala language. Spark is default written in Scala language. Scala is the native language of Spark. So by default, Spark built using Scala language, everything written in Scala. Okay.
Can you show us an example of Scala? Just example prompt.
See, okay. I'll show you when we see in this. Whenever you go with the notebooks, right? Here we work with the notebooks. In the notebooks, it supports all the languages like Scala language, Python, SQL language. All the, it will be supporting. I'll just show you in the practical set. When we deal with the practical, how to if you select Scala, you will get Scala. If you select Python, Python. If you select in this way, whichever language you select, you will be getting it. So Spark related functionalities will be same, only the programming language will be changed. Means language is going to be changed, but whatever the Spark functionalities, everything remains same in all the languages. But only how to define the variables, how to define the functionalities, the collections, the functions that only going to be differed. For example, talk like in Java, in Scala, in Python. Only that the programming may change. For example, in Scala, we say index equal to 10. Here, in Scala, we say var x equal to 10. In Python, just we say x equal to 10. Means in this way, the programming will be changing. Okay.
Got it.
Now coming to this PySpark, you may ask, what is the advantage of PySpark and why PySpark? Why PySpark? Why PySpark, right? Yes. PySpark is the Python API. Is this the Python API, right? You have to use a Spark. PySpark is the Python API to use Spark. So here Python, as I already said, right, Python is providing different modules, thousands of modules it is providing for data science, providing different models for data science, big data, for databases, for all these things, right? Thousands of models. So here even for this data science, right? Yes. Second. For data science, like NumPy, Pandas, Matplotlib, CP, Scikit-learn, TensorFlow, right? Yes. Yes. Fine. For Python API to use Spark. Spark is one of the open source cluster computing system, right, which is used for big data solution. So PySpark is the lightning fast technology that is designed for fast computation, right? The Python API to use Spark. Lightning fast technology, the lightning fast technology. That is designed for fast computation. That is designed for fast computation. It is lightning fast technology that is designed for fast computation. PySpark is the demanding tool. It is the demanding tool. It is a demanding tool among data engineers. PySpark used for running distributed SQL, running distributed, creating data pipelines, ingesting data into a database, ingesting data, running a distributed SQL, creating a data pipelines, ingesting data into a database. Working with the graph and data streams. Distributed SQL for creating data pipelines, ingesting data into a database, running ML algorithms, working with the graph and for data streams. Need for Python. PySpark means large amount of data is generated through online and offline. This data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful business information. But it is necessary to extract valuable information from the raw data. So here we require some efficient tools to perform different types of operations on the big data. So there are various tools already available to perform multiple operations or multiple tasks on the huge data set. But those tools are not so appealing. So it is required we need to have some scalable and some flexible tools to crack big data and gaining benefit from it. So PySpark is such a kind. So PySpark is such a
So here you are saying running machine learning algorithms. So meaning Gen AI tools, that sort of thing.
see here, not like see Spark MLlib library is there. Spark machine learning library also it's provided. Spark is providing many libraries. So, sorry, Python is providing. See in Spark core programming is there. Spark SQL, Spark graphics, Spark MLlib. Like Spark is providing many functionalities. In the initial versions of Spark, it was a little weaker in the machine learning kinds of things. But later it has got some powerful libraries towards this machine learning, right? Machine learning kinds of. So Spark has got a separate library for MLlib. Spark MLlib is available. people who wants to go with those things, right? You can make use of Spark MLlib library. You want some kind of querying, Spark SQL is there and Spark core programming, right? In this way, we have what Spark is providing many functionalities. Need for okay. So combining of Python and Spark will be the very efficient for the world of big data. That's why Apache Spark community, they came up with a tool called PySpark. Apache Spark community came up with a tool called PySpark. This Python API to use Spark. Python API to use Spark, right? Yes. Just now you asked, right? So just now you asked. Python is there and Scala is there. So implementing Spark with Python and Spark with Scala, which one is more beneficial, right? So see the difference. Dynamic type. Python is dynamic type. Scala is statically. Python is dynamic type. Scala is statically typed. As compared to Scala, but Python is, and because Python is interpreted is dynamic type. Scala is statically typed.
Now, can you explain what do you mean by dynamic typed and a static type? The first point.
Whenever you say exec,
Mm.
based upon the value assigned, based upon the what value assigned, the variable is created dynamically. If you're assigning a integer value, integer variable creates. Assigning a float value, float
Okay.
variable creates. Assigning string value, string variables create. But if you see in Scala, like not like that.
Okay.
Explicitly, we need to say like that. But here, based upon the value assigned only, the variables are going to get created. That is dynamic.
Okay. So it assigns the data type according to. Okay.
Programming will explicitly say string set. Directly, you can say x equal to 10. Integer value, integer variable x. Python has a Scala.
Hey, your voice is cracking. I can't hear you.
Yes, sir. I am also getting that noise when you speak.
Getting nice for speaking.
Yes, yes.
Yes, sir.
Now still it is there.
Sir, in between it is happening when you are explaining the topics.
Python has a huge
Now it
community.
is better, sir.
Scala,
Yes, sir. Now we are not.
scalar community is less. Scalar community is less. The audio pin was not plugged properly. Right? Just I adjusted it. Python has a huge community. Scala community is less. And also like Python has powerful libraries. 89,300 modules and supports. Predefined. Scalars libraries are okay. Only one thing is it is a little bit faster than Python. Apart from that, everything Python has got the advantages. PySpark features. In-memory computation. Lazy evolution. Persistence. Partitioned. Powerful fault tolerant. Immutable. Passive MPP. Okay. In-memory computation means storage and processing. This in a single line, I'll say storage and processing. Storage and processing. Storage and processing within the memory level. That is RAM level. Storage and processing within the memory level. That is RAM level. Lazy evolution. Storage and processing within the memory level. That is RAM level. Lazy evolution, right? Lazy evolution. What do you mean by lazy evolution and active evolution? Active evolution means, for example, what is lazy evolution and active evolution, and which one is better? Active evolution means, for example, a labor example. You are making notes daily, and you are after the session you are reading the notes and you are going through the notes, right? That is what active evolution. Immediately after the session, you are just reading it and you are. Lazy evolution means for the next 1 month you won't read, you won't go through the notes. Whenever exam is kept, then only if exam kept only you will read. That is what lazy evolution. But for example, whenever I define something, immediately executing, it is active evolution. Not like whenever I perform some action, then only executing is lazy evolution. For example, um, programming languages, you see functions concept, right? If you make a function call, then only that executes. If no function call, the function won't execute. Here also lazy evolution means what? Whenever you perform any action only, then executing the entire data flow. If you provide any action, then only data flow executes.
In most of the languages, right? Until we call the function, it will not execute, right?
Yes. This is lazy evolution. Here also in Spark, data flows, right? They won't execute automatically. If you provide any action only, then the data flow executes from the start to the end. reusing already executed transformation. Reusing already executed transformation. Reusing already executed transformation. Reusing already executed transformation.
What exactly it is? Yes, explain.
Reusing
Using
already already executed
information.
transformation. So here no need to re-execute. No need to re-execute. Just reuse. No need to re-execute. Just reuse. Means here what is that? If you have executed some transformation, you got the output. Again tomorrow same such task. Again no need to re-execute. You can directly make use of the transformation. For example, if you want department wise the total, for example, if you are performing some aggregations, departments I want total revenue. Tomorrow I want average revenue. For that, the department as the salaries are extracted. For that extracting process, some steps are involved, and finally they are extracted. Later you perform like sum or average kind of functions. But before that, you are extracting that particular everything, right? So already yesterday you have extracted that particular columns. Again, you no need to write again the steps for various steps involved, right? You can no need to re-execute, just reuse that. For example, to make you understand this persistence, I'll show you with multiple examples. We'll be discussing it. This is your flow. A, B, C is there. The C output is used by D. It is used by E. And here also F, G. Already this flow got executed. You got the output of this. This output you got. The second flow, if you want to execute, no need to execute from the beginning. Directly up to here, you got the output right previously. That output onwards, you can execute only from C, F, G. No need to again start from the beginning. Already the C output you can take and compute. So already executed, already the C is executed in the first task. This task 1, this task 2. Already task 1 executed. Already in the task 1 you got the C output. That output you take and compute it. CFG. Again, no need to re-execute from the beginning. The same way, T1, T2, this way T50 is there. From T50 onwards, here you got one, here you got one. This is T80, this is T90. Already this one executed. Already this has got executed. Here again, this T, if you want this output is collected. Okay. Again, to get the output of this, no need to re-execute again from the starting. Directly take T50 to 290, you execute. Already T50 output is there. So already the executed transformation output you can reuse and compute. Again, no need to re-execute from the beginning. Okay, understood now? Yes. 50 steps decreased right here for the task 2.
Yes,
So the
sir.
task 50 steps got to decrease. No need to re-execute. We can reuse already executed transformation. It's a data flow, right? Partitions, Spark data objects. Spark data. Spark data is divided into partitions. Spark data is divided into partitions. Then only parallel processing is, then only we can have parallel processing. If Spark data is divided into partitions only, then only we can have parallel processing. If it is stored in a single system, where can you see the parallel processing? If the Spark data is divided into multiple partitions, if they are stored across multiple systems, then the multiple systems will execute parallelly. Powerful fault tolerant model. Powerful fault tolerant model. Powerful fault tolerant model, right? Yes. Means fault tolerance means a Spark data is distributed across multiple systems. A Spark data is distributed across multiple systems. If any system goes down, then Spark has the capability of regenerating the lost partition. Okay, fine. That's fault immutable. Spark data objects are immutable. The original data cannot be changed or modified. Massive parallel. This is what? Massive parallel process. Spark data partitions. Spark data partitions are distributed across multiple systems that are processed parallel. So this is Spark features. So I was just showing how defining Apache Spark, the Spark evolution of Apache Spark in memory computation. Spark can be coded with why PySpark required, need for PySpark, and Python, and differences between Python and Scala, right? And PySpark features. This introduction to this PySpark, right? Yes. So I'll also give introduction to this in the tomorrow session. I'll be briefing you about this Azure Databricks, why Azure Databricks. So the execution happens using PySpark. Now, what is Databricks and what Azure Databricks means? The total I'll be briefing you, and later we'll be going with the practical part. After tomorrow's class, just will have some more discussions like how this Spark computation is going to happen. Some more like we'll spend some 2 or 3 more sessions like you to clearly understand how the Spark computation happens. Spark data objects are going to get computed, right? Those things you need to understand. So okay. So from tomorrow, just yes.
So can you explain me about the powerful fault tolerant part? Meaning I'm not able to understand the partitions concept.
See, these things, what do you mean by persistence? What do you mean by partitioning? What do you mean by lazy evolution? What is powerful fault tolerant? All this again we'll be discussing in brief. Just it's an overview like PySpark features. Powerful fault tolerant means simple. Spark data is distributed across multiple systems, multiple RAMs of multiple systems. If any system goes down, then the data is lost, means partition is lost. But Spark has the capability of regenerating the lost partition. How it can, we'll be discussing. So all these things I'll be discussing again. Lazy, what do you mean by lazy evolution? What do you mean by persistence? What are the various rules you need to follow while persistence? What do you mean by fault tolerance? What are the different cases in fault tolerance? Everything I'll be discussing. So before I go with the Databricks, let me discuss about this lazy evolution, persistence, partition, and powerful fault tolerance model, and how Spark data objects are getting processed. How the Spark data objects are getting processed. Okay. So before we practical part, we have got some discussions, right? You need to understand clearly about this PySpark computation. Okay. I'll be discussing about all these things in brief again, right? Okay. So for today, I'll stop. We'll continue tomorrow, same time at 6 o'clock to see more discussion on this, right? Yes. Right. Right.
Thank you.
Okay, sir.
Try to
Thank
be
you.
try to be regular to the sessions, everyone, and try to interact during the sessions, right? Fine. If you miss any 1-2 sessions, right, it will be very tough for you to understand the next sessions, right? Yes. Okay.
Sir, only Friday attend. I have entire day means department meeting. Otherwise, I'll attend all. No issues with that.
If you miss any session,
Okay,
also try to immediately go with the recordings and try to attend the
Yeah.
next class to better
Yeah.
understand.
I will do that. Yes, sir. Sure.